So to get started, the first thing we're going to do is we're going to go ahead and set up our development environment. And the course files that are provided to you, there should be a starter code zip folder. And if you go ahead and extract that contents, you should see a JavaScript folder, an assets folder, and an index.html page. And what we're going to do is we're going to go ahead and open up these assets inside VS Code. So to go ahead and open up our project folder in VS Code, what we can do is go ahead and click on this icon over here, and we can go ahead and right click and choose Add Folder to Workspace. And then what we can do is go ahead and navigate to that folder that we extracted, and I'll go ahead and add it into VS Code here. If you don't want to add the folder to your current workspace, another option is you come up to File, you go ahead and click on Open. If you go ahead and choose that folder, it'll go ahead and open that folder as the default folder for a new workspace. So real quick, what we're going to do is we're going to go ahead and review the files that are included. So the index.html page is a basic HTML page that just has a meta tag, the title tag, and a few scripts included. So one is for the Babylon.js library, and the second one is for a file called main.js. So if we go ahead and take a look at those, we'll see main.js, we just have a console log, and then we have this reference up here. So if you're not familiar with this, this allows us to provide a types definitions file for some type of library or external JavaScript source. And what it does is VS Code will recognize this, and it will allow us to have auto-completion when we're referencing that vendor library. So just for example, if I go ahead and type Babylon and do dot, and you'll see that VS Code picks up all the type definitions for Babylon.js, and it gives me access to all of the properties and the methods that are available on this global object. So normally if we didn't include this, when we did dot, we wouldn't have any auto-completion because VS Code wouldn't be aware of what's available for this JavaScript object. So normally with your type definition files, this is usually used in TypeScript projects, but you can utilize them in projects where you're not using TypeScript, but you'll have to include references like this. The other option is if you use npm to install your vendor libraries and you import them that way, usually VS Code will detect the types that way, and we won't have to include this. However, that's out of scope for this course, and we'll be using this method for the rest of the course. So in our vendor folder, you'll see we have the Babylon.js file, as well as the type definition file that I mentioned. Lastly, we have an assets folder, and this just includes some images and models that we'll be using in our course. And we'll get to those later. So the last thing we need to do for setting up our development environment is we need to go ahead and have some type of development server. And for this course, I'll be making use of an extension that's available in VS Code that you can install. And this is called Live Server, and it's by Ritwork a Day. And basically what this server does is going to start a development server for you inside from VS Code, and it will have hot reload enabled out of the box. So the main reason we're doing this is if we're loading any files that we have locally while working with our JavaScript code, our browser will go ahead and block that for security reasons. And so we need some type of development server to serve these resources so we can load them in that way. The other benefit is by having the hot reload, we can have our browser refresh automatically anytime we make changes, and so we can easily test our code without having to do a manual refresh. So to go ahead and install this extension, what you want to do is go and click on extensions here, and you want to go ahead and search for Live Server, and you should see this here, and you want to go ahead and click on the install button. And then once it's installed, what should happen is you should get this little button down here that says Go Live, and this is for the live server. And if you don't see that button there, the other way you can start the server is if you go ahead and come up to View and go to Command Palette, or if you use the shortcut, this will open up your command palette here, and you can go ahead and just search for Live Server, and then you should see the commands that are available. So go ahead and click on Open with Live Server. If you have multiple folders in a workspace, you have to choose it. Otherwise, it'll just use your default folder. So I'm just going to go ahead and click on our Babylon.js. And what should happen is a new tab should open in your default browser at port 550. And what we should see is if we go ahead and open up our console, we should see Hello World. So the page should be blank right now because there's nothing on an index.html page. But if we open up our console, we should see Hello World. So now that we have our development environment set up, we can go ahead and start creating our first 3D scene. So the first thing we need to do is we actually need to create a canvas element. So with WebGL, all of our content will be rendered to the HTML canvas. And so we need to have this element on our page, so that way with Babylon.js we can go ahead and reference our canvas element and then go ahead and start creating our objects there. So what we'll do is in our index.html file, let's go ahead and create a canvas element, and let's go ahead and give it an ID of render canvas. And then what we'll do is let's go ahead and add a style to our page. So we'll go ahead and do style, and we'll go ahead and target our canvas element that we added, and we'll go ahead and add width, and we'll go ahead and set it to 100%, and we'll go ahead and do height, and we'll go ahead and set that to 100% as well. And then next, let's go ahead and target our HTML and our body element. Let's go ahead and add a margin, and we'll go ahead and set it equal to 0. So that way, what should be happening is our canvas should go ahead and take up our full width and height that's available. So you'll see right here is taking the max width and height that's available right now for this particular screen size. So now that we have our canvas element, we can go ahead and switch to our JavaScript file, and what we'll do is let's go ahead and get rid of our console log. And as I mentioned, we need to go ahead and use our canvas element so that we can go ahead and reference that by its ID. So let's go ahead and get our canvas. So we'll go ahead and do const canvas equals document.getElement by ID, and we'll go ahead and do render canvas. Once we have our canvas element, the first thing we need to do with Babylon.js is we need to go ahead and create an engine. So this is going to be our WebGL engine. It's going to be used for rendering out all of our objects, our cameras, our lights, and everything we want to put in our 3D scene. Our engine is going to be in charge for doing that. So what we'll do is we'll create a Babylon.js engine. So we can do that by doing const engine will be equal to new Babylon.engine. And then in our constructor, we want to go ahead and pass in our canvas or our WebGL context. So we'll go ahead and pass in the canvas elements since we're referencing that. Next, we go ahead and pass in an optional argument if we want to go ahead and enable anti-aliasing. So we're going to go ahead and pass in true, so that way we can enable that. So after we have our engine, we actually need to go ahead and create our Babylon scene. So our scene is going to have a few things associated with it. First is going to be a camera. So kind of like a movie or when we're taking a picture, we're going to have a camera that's going to be showing our scene. And we can move and we can make our camera interactive so the user can move it around and they can view our 3D scene so they can see it from different angles. We can also allow our camera to rotate so we can move it around the scene. We can allow it to zoom in and different things like that. Next, we're going to have our light. So our light is how we're going to be light up our scene. So when we create our scene, it's kind of like a box, and inside this box, we don't see anything because there's no light. But as soon as we put a light inside this box, everything lights up, and we can see all of the objects that we've put in there. So we'll need a light in order to light up our scene. So let's go ahead and just add some comments. We're going to create a scene, and then we're going to go ahead and create a camera, and then we're going to go ahead and create a light. So for creating a scene, we're going to go ahead and do a function. So we're going to do function create scene. And in here, when we create our scene, this is where we're actually going to go ahead and create our camera and our light. So we'll go ahead and place that in here. And let's go ahead and add our comment for creating a scene inside there as well. So to go ahead and create a scene, what we'll do is we'll do const scene, and we'll set it equal to new Babylon dot scene. And then for the arguments we need to pass, we need to go ahead and pass in our engine that we created. So we'll go ahead and pass that in. And then what we'll do real quick is at the bottom of our create scene, we're just going to go ahead and return our scene object that we create. So now we need to go ahead and create our camera. And in Babylon.js, there are a variety of different camera options that are available to you. And the first camera we're going to take a look at is called a free camera. So basically a free camera in our game is kind of like a camera you would see in a first-person shooter game. So we'd be seeing everything from a first-person perspective, and we'd be able to move our camera, and it'd be like we're the ones moving inside this scene. So this will be the first camera we'll be taking a look at. So to go ahead and create this type of camera, we'll do const camera. We'll set it equal to new Babylon dot free camera. And then for our arguments, the first thing we need to do is we actually need to give our camera a name. So I'm just going to call it camera. Next, we need to go ahead and give it a position. So our position is going to be a vector 3. So this is going to be an x, a y, and a z coordinate. So the coordinate system in Babylon.js consists of 3 coordinates since we're working in the 3D space. And so basically our x coordinate is going to be our axis like this. So we'll have our negative values and then our positive values over here with the center being 0. Our y will be our vertical axis like this, so we'll have positive and then negative values centered on 0. And so z will go ahead and be our depth, with 0 being right in front of us, and then as you move away, it'll be positive, and as we zoom closer, and as it comes towards you, it would be negative. So to go ahead and create our vector 3, what we'll do is we'll do new Babylon.vector3. And we'll go ahead and just specify 0, 0, and 0 for our position. So we'll just go ahead and put this in the center of our scene. And then next we need to go ahead and pass in our scene. So we'll go ahead and pass that in. All right, and so now that we have our camera, we need to go ahead and actually create a light to go ahead and light up our scene. So to do that, we'll do const, and we'll do light equals new Babylon dot hemispheric light. So similar to cameras, Babylon offers many different light options, and so the first light we'll be taking a look at is our hemispheric light. So a hemispheric light, so it's kind of like a light in a room. It'll be up on your ceiling, and the light kind of points downward on you. For our arguments, we need to go ahead and provide a name. So we're just going to call this light. Next, we need to go ahead and provide a direction from where the light is coming from. So to do that, we need to do our vector 3. So we'll do new Babylon dot vector 3, and we're going to go ahead and pass in 0, 1, 0. So that way the light will be from above. And then we need to go ahead and pass in our scene. So then what we need to do is we need to go ahead and create our scene instance. So we'll go ahead and come down here. We'll create our scene. So we'll do const scene equals create scene. All right, and then after we have our scene, the last thing we need to do is we need to actually tell our Babylon engine to go ahead and render it out to our canvas element. So to do that, what we do is we do engine. We go ahead and run render loop. And then we can go ahead and pass in a function. And inside this function, we're going to call the render method on our scene. So we'll do scene.render. I'll go ahead and save. And so you'll see right away that we have something rendering out to our canvas element here. So what we did here is we called the run render loop method on our engine. And so what this does is it allows us to register a function that'll be invoked every time we enter a new frame when our engine's running. And by us registering this function, we're able to render out our scene, and allows us to do things like create animations so that we can have objects moving in our scene. So it'll no longer be a still image. We'll actually be able to see that animation play out, so kind of like a movie. So now we know how to create our basic scene. Our next step is we want to go ahead and actually add 3D objects to our scene. So in Babylon.js, we have 2 different types of elements that we can create. The first are our basic elements. So these are like our basic shapes, such as a box, a sphere, or a plane. And then there's another type called a parametric shape. And basically, these are shapes that don't have like an everyday name. And these are created by using some type of mathematical data to formulate what we want. So for example, we create multiple lines by just providing coordinates, and then the lines will be drawing between these points. And with this, we can create all kinds of different 3D shapes by using the points and other methods that are available to us. So to start off, we're going to start with our basic shapes. And out of the box, Babylon.js offers what is called the Mesh Builder. And generally what the Mesh Builder method allows us to do is we basically just do meshbuilder.createShape. and create shape will be the method of the shape we want to create. So for example, create box. And when we call this method, we provide a name, our scene, and then the options to create the objects we want to create. So what we're going to do is if we can go ahead and go to our create scene function, after we create our light, let's go ahead and add a new line, and we're going to go ahead and create a box. So we're going to go ahead and do a new variable. We'll call it box, and we'll set it equal to Babylon.meshbuilder.create box. So for our first, so as I mentioned, for our first argument, we're going to go ahead and pass the name. So we're just going to go ahead and call it box. Next is going to be the options for our box. So I'm just going to go ahead and pass an empty object for now. And then we want to go ahead and pass in our scene reference. So we're going to go ahead and pass in scene. All right, so go ahead and save. It looks like nothing's created our scene. So what's happening here is our box is being placed at the exact same position as our camera, so we can't really see our box. So what we're going to do is we're going to go ahead and update the position of our camera. And I'm just going to go ahead and do -10, -5. There, so now that we see, so now we can see that our box was created. So as I mentioned, we can go ahead and pass options to our box. So if we don't pass anything, all the default values will be utilized, but we can pass things in like the size. So if I want to go ahead and change, the default value is 1, so I'm going to change this to 10. And so now you'll see that if I move the camera back, our box is a lot larger than it was before. We can also pass things in like our width, our depth, and everything like that, so that we can create things like a rectangle. All right, so what I'm going to do is I'm going to go ahead and set this back to 1, and I'm going to go ahead and move my camera a little bit closer, and we'll go ahead and just do -10. Perfect. So next, we're going to go ahead and look at creating a sphere. So we're going to do create a sphere, and so we're going to do const, and we will do sphere. We'll set equal to Babylon.meshbuilder.create sphere. And we'll go ahead and just name it sphere. Go ahead and pass in an empty object for our options, and we'll go ahead and pass in our scene. We'll go ahead and save. And so right now our sphere is being created at the exact same location as our box. We want to go ahead and actually update its position. So to do this, we can do sphere. We'll do dot position, and then we can go ahead and provide a vector 3 of where we want our sphere to be located at. So I'm going to go ahead and do set it equal to new Babylon vector 3. And let's go ahead and just update the x. We'll do 5, 0, 0. We'll go ahead and save. And so now we can see our sphere was created in our scene over here. So let's actually move a little bit closer to our box. We'll do 3. So let's go ahead and move our camera just a little bit closer so we can actually see our objects. And so right now our sphere is pretty round. And so one of the options we can pass when we create our sphere is segments. And so just to kind of see an example, what I'm going to do is I'm going to go ahead and set this to 5. And what we see is our sphere is no longer as round as it was before. So our segments are the number of horizontal pieces that make up our component. So when by default this is 32, so we have a lot more lines on our ball, so it gives it a really round look. And when we drop this number down, we have less of those segments, so then our ball looks more polygonal. So as I mentioned, by default 32, and then we get this really nice looking ball here. All right, and then another option that we can pass is our diameter, and this is how big our sphere is going to be. So I'm going to do diameter. So by default, it's set to 1. So if we save, nothing should change. But if I go ahead and bump this up to 5, you'll see our ball gets very, very large. So if we do 2, we just get twice as large. Next, we're going to look at creating a plane. So we're going to do create a plane. So we're going to do const plane equals Babylon.meshbuilder. We'll do create plane, and we're just going to call it plane. We'll use the default options, and we'll pass in our scene. All right, so similar to what we did to our sphere, we're rendering our plane at our origin here, so it's being covered up by our box. So what we'll do is we're going to update our position on our plane. We'll do plane position. We'll go ahead and set this to -3. If we go ahead and save, our plane's being rendered, but it looks a lot like our box. And so what we're going to do is we're going to go ahead and add a controller to our camera so we can actually move our camera around, and that way we can actually see our objects more in the 3D space. So to do this, we can do camera dot attach control, And then we go ahead and provide our elements, or HTML element we're attaching our camera to. So we're going to go ahead and attach our canvas, and then we'll go ahead and pass true. So if we go ahead and save, let's make our scene a little bit bigger. Now if we use our mouse and click on our canvas, we can actually move our camera. And then if you use the arrows, you can actually move your camera back and forth. And now if we take a look at our objects, so you'll see our plane is not actually a box, and we can actually see that it is a plane when we look at it in the 3D space. So as you can see, using our mesh builder to create our objects is very easy to do. And there are a lot of methods available to us to create all kinds of different objects. So just for example, if I do Babylon.meshbuilder, if we take a look at our auto completion, we have a bunch of different methods available to us, like creating polygons, ribbons, tiled boxes, torus, knots, tubes. We can create things like cylinders and much, much more. And all these are available right out of the box. So the next object we're going to take a look at is one of our parametric shapes. So as I mentioned, when we create these shapes, they're different than our basic elements because we actually have to provide some type of mathematical data to create this instance. So what we're going to do is we're going to go ahead and draw a line consisting of multiple points. So to do that, what we're going to do is let's set a comment, create a line. First, we're going to create an array to store our points. So we're going to do my points, and we're going to do points. We'll set it to an empty array. And then what we'll do is inside our array, we're going to do a new Babylon.vector3. And we'll go ahead and start at our origin. So we'll do 0, 0, 0. And what we'll do is we'll copy this line. And next, we'll go ahead and have it go to position 1, 1. Oh, actually, we'll have it go to position 1, 1, and then we'll go to 1, 0. And then what we want to do is we want to use our mesh builder to create our line. So we'll do const lines will equal Babylon.meshbuilder.create lines. And then we want to go ahead and pass in our names. We'll do lines. And then for our options, what we'll do is we'll do points, and we'll set it equal to our array. So we'll do points. So we'll just do our shorthand. And then we want to go ahead and pass in our scene. And so what we'll do, so our lines are coming out of our box here. So what we'll do is we're going to go ahead and actually update our position. So we're going to actually start at 2, 0, 0, and we'll go to 2, 1, 1, 2, 1, 0. So now if we take a look at our scene, you can see that we've rendered out our line. And so with this, we can draw all kinds of different objects to our scene. So now that we know how to create our basic shapes, we're going to take a look at how we can update the position of our objects and how we can update the rotation and the scaling of our objects to modify them in our scene. In our previous lesson, we learned how we could update the position of our objects by using the position property on them, and we can provide a vector 3 to actually move our object. We want to go ahead and dive in a little bit deeper to this. So when we want to update that position, we have to provide 3 values, and this is our x, y, and z. And so these are in relation to the origin, so our world axis, and our scene. So you'll see here, like we wanted to update our sphere, we provided a vector 3 of 3, 0, 0. And so our sphere in our current scene here, basically what we did is we updated the x value. So that would be like this red line here. So in our scene, our origin is right here, 0, 0. So when we provided a positive value, we moved our object in this direction. Then we provided 0 for our y, our green line here, and 0 for our z, so our blue line here. So that's why when our sphere was positioned to the right, it's only because we updated that x value. If we would have updated the y value, it would have moved up in our scene, and then z would have made it either go further or closer to our camera, because that'd be the depth. Similar for our plane when we provide the negative x value. So in addition to providing vector 3s, we can also actually update each value individually, and we can do that by doing plane.position and then the value that we want to update itself. So in addition to updating the position, we can actually also rotate our objects. And that's also done by using the property on our object itself. So what we'll do is we're going to come up to our box, and what I'm going to do is I'm going to do box.rotation. And so similar to like our position, we can provide a vector 3 if we want to provide a value for each of them, or we can access the individual values directly. So I'm going to do .x, and I'm going to go ahead and set it equal to 2. And so you'll see right away, our box has been rotated along our x-axis, and so it's been rotated a little bit in this direction. So then what we can do, if I want to rotate it around the y-axis, I'm going to go ahead and just change this to 3, then our box will rotate along that axis as well. So in addition to rotating our objects, we can also scale them to make them bigger or larger. So what I'm going to do is I'm going to go ahead and come down to our sphere. So when we go ahead and scale our objects, we go ahead and use the scaling property. So what we'll do is we'll do sphere.scaling. And so similar to our position and rotation, we can provide a new vector 3 for each of the axes, or we can go ahead and access the individual values directly. So what I'm going to do is I'm going to do a new Babylon 3, a new Babylon vector 3, and I'm going to go ahead and do 1, 1, 1, and we'll go ahead and save. And so what I did here is I went ahead and scaled the object by its current size. So by default, our scaling is always set to 1, so that's why it looks like our sphere didn't change, because I left it at its default size. However, if I come in here into my y value, if I change this to 0.5, I now took my object and I scaled it to half of its size using the y-axis. So that's why in our sphere here, we're squishing from the top and the bottom, and we get this egg-looking object here. So if I go ahead and change this to something like 0.7, we should still see the squish effect, but just not as much. And if I change to something like 0.2, we see it's a lot bigger, and I just shrunk our object along our y-axis, so it's only 0.20% of the size it was before. So similar to doing it to our y, we can do it on our x-axis here. So if I change this to 0.5, you'll see that our object is shrunk in our x direction, or on our x-axis. So you see if I do something like 0.2, we get this object that's kind of thin and flattened, and it looks kind of like a piece of candy. So if I go ahead and do the z-axis, you'll see that scales our object even more. And then what we can do is if we just kind of wanted to make our object half of its size, we could set them all to 0.5, and we'll still have a sphere, and it's just half as large as it was before. So kind of as a recap, we learned how we can go ahead and modify the position of our objects by the x, y, or z axis on that object. We also learned how we could either provide a vector 3 or access those properties individually, so our x, y, and z values. And we also saw how we can do this with our rotation and our scaling properties on our objects. We saw how we could rotate our objects to change them in our scene, and we saw how we could scale them to make them larger or smaller. So now that we've seen how we can modify our objects, the next step we're going to do is we're going to learn how we can actually color them. So right now, all of the objects in our scene are this dull gray color, and then you can see our light source hitting it and it's reflecting off of it, so we get a little bit of shadow on the objects. And so this is great for prototyping things. However, we want to bring our objects to life, and one way to do this is we can use materials. So materials allow us to cover our meshes in color and textures, and they will need a light source in order to be seen in our scene. Another cool thing about our materials is once we create them, we can apply them to multiple objects. So we don't need to create a material for each object if we don't want to. So when we go to create our materials, there are a few different ways that our materials can react to light. So this is important because depending on the color type that we modify on our material, the light's going to reflect differently. So just for example, if I update our diffuse color, this is going to affect how the materials actually being viewed under the light source. Where if I want to modify our specular color, this is going to modify the highlight that's given off when the light hits it. So kind of like our highlight here, right now it's defaulting to white. If I had a material and I changed that color, the highlight could be a different color. And this is important to keep in mind when you're modifying your scene, because depending on your materials, it might not give off the effect that you were looking for. So to get started, what we're going to do is we're going to go ahead and create our first material. So what we'll do is in our create scene function at the bottom, we're going to go ahead and add a comment. We'll do create a material. So to create a material, what we'll do is we'll create a variable. So we'll do material. And I'm going to go ahead and set it equal to new Babylon. And then we want to go ahead and do standard material. And then we need to go ahead and provide a name and our scene reference. So I'm just going to do material, and we'll go ahead and pass in our scene. So all this does is create a material object that we can assign to one of our objects. So until we actually update our object to use this material, we're not going to see any differences in our scene. So to do that, what we do is we do one of our objects. So I'm going to do our box, and then I'm going to go ahead and do material, and I'm going to set it equal to the material that we just created. So here we've updated our material, we applied it to our box, and we updated our scene, but it doesn't look like anything's actually happening. And so by default, our material has this gray color that we've been using for all of our objects. So any object that we don't assign a material to will have this default color and this default material. So to see some type of change, what we want to do is we want to update one of our colors on our material. So the first color we're going to do is we're going to go ahead and update our diffuse color. So we're going to do material, we'll do our diffuse color. And what we're going to do is we're going to set it to a new Babylon.color3. And then what this does, it allows us to provide RGB values for our color that we like to utilize. So for red, we'll do 1. Our green, we'll do 0. And we'll do 1 for blue. So these values we provide are between 0 and 1 inclusive. So this is the amount of color that will be applied to this material. So then we end up resulting in this purple color, where if I do 1, 1, 1, we'll end up with like a white color. And if we do 0, 0, 0, we'll have black. And if we go ahead and just change this, so for example, if I want to just do a red cube, I can provide 1, and now I have this red looking cube. So as I mentioned, depending on the color we update, it affects our object differently. So our diffuse color is the color of our material that it will be shown when there's a light in our scene. So because our diffuse color is red and we have a light in our scene, we're able to see this color. Now, if I go up to our light, and if I go ahead and remove it, you'll see now our diffuse color on all of our objects is showing black, because by default our diffuse color was gray, and in our box it's red color. And so without that light, we can't see our colors. It's kind of like we're in a dark room. So as I mentioned, there are multiple colors that we can modify in our materials. So I'm going to go ahead and update our emissive color on our materials. We'll do material.emissive color. I'm going to go ahead and copy our color 3 here. I'm just going to change it all to 0. So you'll see here that we're providing black, so there's no color change happening here. But if I go ahead and update our green value to be 1, all of a sudden our material completely changes and it's a completely different color. And so the top of our box looks yellow, and the reason for that is because we have our green being emitted from our box. We have our green color because it's self-lit, and then we have our ambient light in the top of our scene also applying the color to our box, to our material, to light it up. And so we get this different looking color here. And so if we just kind of navigate around our scene a little bit, when we take a look at it, we'll see that our cube has different colors depending on how it's viewed in the light source being applied to it. So in addition to applying colors to our material, we can also apply textures. And so our textures allow us to use external images to texture our objects depending on that image. So just kind of as an example, what I'm going to do is I'm just going to go ahead and copy our material here. I'm going to create a new variable. I'm just going to call this material2, and I'll update the name as well. All right, and then we actually need to go ahead and apply the texture to our material. So I'm going to do a material2 dot, I'll do a diffuse texture, and we'll set equal to a new Babylon.texture. So we need to go ahead and provide the path to our image that we like to utilize. So I'm going to do assets.images, and I'm going to do darkrock.png. And then we need to provide our scene. And then finally, like our other material, we just need to assign it to an object. So I'm going to do our sphere, and I'm going to do sphere.material, and I'll set it equal to our material2. So now if we go ahead and save, when we take a look at our scene, we can see that our sphere has our image being applied to it as a texture. So similar to the different colors that we have available to us, we also have different types of textures available. And for each one, the light will affect it differently. So kind of like before we had diffuse color and emissive color, we also have diffuse texture and also emissive texture. And likewise, because we're using a diffuse texture, we're reliant on a light source in our scene for our material to actually show up on our object. So as an example, if I remove our light source, we no longer see the material on our object. So just as a quick recap, in this lesson, we learned how we could create materials, be it either a color material or a texture, and we saw how we can apply these to our objects. And we saw how we can modify the different color properties on these materials to affect the color and the lighting of our objects.